All right, so we're doing practice C problem 3 for physics chapter 6. It says, assume that a car in problem C has a mass of 3250 kilograms. How much force would be required to cause the same acceleration as an item 1? And then how far would the car move before stopping? And this is a really annoying problem because it references like all the other problems in this practice. So we're going to start. We're looking at sample C. Sample C, it's a scenario is that this car is going west and slows with a constant acceleration from 20 meters per second to 5 meters per second. And based on that, item 1 tells us that the time for this car to come to a complete stop is 5.33 seconds, right? So the first part of this problem asks us to find the same acceleration as item 1 right here. That means we have to use this equation, F equals mass times velocity final minus mass times velocity initial over delta t, which is just a variation of this equation. That's the impulse momentum theorem. So we have this. We have it solved with force isolated. All we have to do is plug in our numbers. So we have 3250 kilograms. Plug that in for m. Velocity final is 0. Since in item 1 the car comes to a complete stop, we subtract the same mass times velocity initial, which is 20 meters per second, as told in sample C. Plug that into a calculator, divide over the time, and we should get to this answer. That's the amount of force needed to slow down this car at the same rate as sample C. Now we move on to part B. How far would the car move before stopping? So this is more of a kinematics problem. We have to do, you have to use the force, it tells us. So A equals F over M. Plug in your force, found here, found down in A. Plug that in, divide by the mass, and you should get 3.75 meters per second squared. That is the acceleration of item 1 in sample C. Now we have to use that in the kinematic equation here. The basic one, delta x equals velocity initial times time plus 1/2 at squared. All right. So we plug those numbers in, plug it into a calculator, and boom. You should get 53.3 meters west, right? So usually all you have to do once you find your numbers is just get an appropriate equation and plug it in. So in this case, once we found the force, we know how much the acceleration is. Once we know how much the acceleration is, we can find out how far Earth's displacement based on the time. And time is given to us in uh, item 1. So we have all the numbers we need. We just plug it in, and that's it.